On December 6th, a NASA spacecraft that had circled Mars for more than 11 straight years simply vanished. One moment, every single system on board was reporting perfectly normal readings. The next moment, after a routine pass behind the planet, nothing. No signal, no data, no response. NASA spent 6 full months quietly trying to bring it back before finally admitting the truth this year. The spacecraft was gone for good, and nobody yet fully understands why. This is the real story of Maven, and it deserves far more attention than it has gotten, because this was not some minor technical hiccup. This marks the first time in the entire history of American space exploration that NASA has accidentally, physically lost a working spacecraft while it was still orbiting another planet. Let's start from the beginning, because understanding what Maven actually was makes this loss hit even harder. Maven stands for Mars Atmosphere and Volatile Evolution, and it launched all the way back in November 2013, arriving at Mars in September 2014. Its original job was supposed to last just 1 year. NASA wanted Maven to answer one specific, enormous question that had puzzled scientists for decades. Why did Mars, a planet that once had a thick atmosphere and flowing liquid water on its surface, end up as the freezing, dry, nearly airless world we see today? What actually happened to all that missing air? Maven was the very first mission NASA ever sent specifically to study this question, and it delivered results almost immediately. Using its onboard instruments, the spacecraft directly measured how the sun's constant stream of charged particles, known as the solar wind, was actively stripping away what remained of the thin Martian atmosphere, one tiny piece at a time. This process, sometimes described by scientists as atmospheric sputtering, had been theorized for years, but Maven gave researchers the first real, direct evidence of it actually happening in real time. That single discovery alone would have justified the entire mission, but Maven kept working and kept discovering, for over a decade beyond what anyone originally expected. Understanding why Mars lost its atmosphere in the first place matters far beyond simple scientific curiosity, too. Billions of years ago, Mars is believed to have had a much thicker atmosphere and a functioning magnetic field similar in some ways to Earth's own, a magnetic shield capable of deflecting the constant stream of charged particles flowing outward from the sun. At some point in the planet's ancient history, that internal magnetic field weakened dramatically, likely as the planet's molten core gradually cooled. Without that protective magnetic shield, the solar wind was free to directly strike the upper atmosphere, gradually knocking gas molecules loose and carrying them off into space, one tiny collision at a time, over the course of hundreds of millions of years. Maven gave scientists their first real chance to directly measure this ongoing process happening in the present day, rather than simply theorizing about what must have happened in the distant past, based on indirect evidence alone. Instead of the 1 year it was built for, Maven operated successfully for more than 11 years straight, a lifespan roughly 11 times longer than its planned mission. During that extended run, it discovered multiple different types of Martian auroras, lights in the Martian sky caused by charged particles interacting with the planet's weak, patchy magnetic field. It tracked how massive dust storms on the Martian surface affected the thin atmosphere high above. It even studied how a passing comet's debris interacted with the top of the Martian atmosphere during a close flyby years earlier. One of those discoveries deserves a bit more detail, because it captures exactly the kind of unexpected science a long-running mission like this makes possible. Years into its extended mission, Maven happened to be perfectly positioned when a comet from the outer solar system passed unusually close to Mars, close enough that debris and dust streaming off the comet's tail actually brushed directly against the top of the Martian atmosphere. Because Maven was already there, already operating, and already equipped with the right instruments, scientists got a genuinely rare, front-row view of how comet debris temporarily altered the chemistry of an entire planet's upper atmosphere, a kind of natural experiment nobody could have deliberately planned or scheduled in advance. Opportunities like that only exist because a spacecraft happens to still be functioning in the right place at exactly the right unpredictable moment, which is precisely the kind of scientific value that gets permanently lost the instant a mission like Maven suddenly goes silent. All told, data from Maven ended up contributing to more than 800 separate scientific research papers, an extraordinary output for any single planetary science mission. Maven was not simply floating around Mars taking notes either. It also served a genuinely critical, practical purpose for NASA's entire Mars exploration program. Alongside 2 older orbiters, Mars Odyssey and the Mars Reconnaissance Orbiter, Maven acted as a communications relay, receiving data transmitted from NASA's rovers exploring the Martian surface, Curiosity and Perseverance, and forwarding that information back to Earth through NASA's Deep Space Network. Every single day, Maven was quietly helping researchers keep in contact with humanity's active machines, exploring the surface of another planet, work that continued right up until the exact moment it vanished. That relay role deserves a moment of extra attention because it is easy to overlook just how important it actually is. Curiosity and Perseverance, NASA's 2 active rovers crawling across the Martian surface are not built with powerful enough antennas to send large amounts of data directly back to Earth on their own. Instead, they typically transmit their images, readings, and other collected data up to an orbiting relay spacecraft passing overhead, which then forwards that information back across the vast distance separating Earth and Mars using far more powerful equipment. Without a working relay orbiter available at the right moment, a rover's collected data can simply sit unsent, waiting for the next available relay opportunity to come around. Maven had spent years serving as one of the reliable links in that communication chain, meaning its sudden loss did not simply end its own scientific mission. It also removed one of only 3 available relay points connecting 2 active surface rovers back to mission control on Earth. So what actually happened on December 6th? By all accounts, that day started completely normally. Maven had performed this same basic maneuver thousands of times before, without any problem at all, swinging behind Mars as seen from Earth's point of view, then re-emerging on the other side a short while later, right on schedule. Every system on board was reporting clean, normal readings right up until the spacecraft disappeared behind the planet, exactly as expected. Mission controllers had absolutely no reason to expect anything unusual. This was routine, ordinary spaceflight, the kind of maneuver that had become almost boring in its reliability after more than a decade of repetition. The Deep Space Network itself is worth understanding a little better here too, since it is the only reason humanity has any way of knowing what happened to Maven at all. This network consists of enormous radio dish antennas positioned at 3 carefully chosen locations around the globe, spaced roughly evenly apart, so that as the Earth rotates throughout the day, at least one antenna always has a clear line of sight toward Mars, or toward any other spacecraft currently operating deep in the solar system. These antennas are not small pieces of equipment either. Some of the largest dishes in this network stretch well over 200 feet across, engineered specifically to detect radio signals so faint by the time they cross tens of millions of kilometers of empty space that ordinary consumer equipment could never hope to pick them up at all. When mission controllers describe hearing nothing from Maven, they mean these extraordinarily sensitive instruments, capable of detecting whispers of signal from the very edge of our solar system, found absolutely nothing where a clear, strong signal should have been present. Then Maven re-emerged from behind Mars, and NASA's Deep Space Network, the enormous international network of radio antennas used to communicate with spacecraft scattered across the solar system, picked up absolutely nothing. Silence where a signal should have been. Engineers waited, nothing changed. Hours passed, then days, then weeks, then months, with no contact ever restored. NASA released a brief public statement in mid-December, confirming the loss of signal and stating simply that mission controllers were investigating the anomaly, promising more information once it became available. That short, careful statement was, for a long time, essentially all the public had to go on. Behind the scenes, though, engineers were working intensely to figure out exactly what had gone wrong and whether there was any realistic chance of bringing the spacecraft back. In February, NASA formally convened what is known as an Anomaly Review Board, a dedicated team assembled specifically to investigate serious unexplained incidents like this one, tasked with determining both the probable cause of the failure and the likelihood that Maven could ever be recovered. This is not a process NASA takes lightly or rushes through quickly. Anomaly review boards typically involve engineers poring over every scrap of available data, running simulations, testing similar hardware here on Earth, and cross-checking every possible theory before reaching any kind of official conclusion. By June, after months of careful investigation, the review board finally delivered its verdict. Maven was, in their own words, in an unrecoverable state. The mission, one of NASA's most scientifically productive Mars missions in the agency's entire history, was officially declared over. Here's what investigators actually managed to piece together, even though the full root cause still remains unknown. In the brief moments before contact was completely lost, engineers managed to capture a tiny fragment of telemetry data, essentially a last partial message from the spacecraft. That fragment showed something deeply concerning. Maven had entered what is called safe mode, a kind of automatic emergency shutdown state spacecraft use to protect themselves when something goes seriously wrong, and it was spinning at an unusually high rotation rate, far faster than normal. A clear sign that something had disrupted its orbital trajectory or its onboard stabilization systems. Safe mode itself is a standard built-in feature on nearly every spacecraft NASA has ever launched. Essentially a last resort survival mode designed to protect delicate hardware when onboard computers detect a serious problem they were not specifically programmed to handle. In safe mode, a spacecraft typically shuts down all non-essential systems, points its solar panels toward the sun to maximize power generation, and waits patiently for new instructions to arrive from mission control back on Earth. This system has saved countless missions over the decades, giving engineers valuable time to diagnose a problem calmly, rather than losing a spacecraft to a fast-moving cascade of failures. In Maven's case, though, something about the specific nature of this particular anomaly appears to have overwhelmed even that built-in safety system, since the unusual high-speed rotation kept draining power far faster than the safe mode protocol was ever designed to handle. That abnormal spin turned out to be the direct cause of everything that followed. According to the review board's findings, this unexpected high-speed rotation ended up draining the spacecraft's batteries far faster than they were designed to handle. Once those batteries ran down completely, Maven's communication system lost all power entirely. And once a spacecraft that far from Earth loses power to its communication system, there is genuinely no way for engineers on the ground to send any command capable of fixing the problem, because there is no longer any way for that command to actually be received or acted upon in the first place. The spacecraft, for all practical purposes, went permanently deaf and mute at the exact same moment. What actually triggered that initial abnormal spin in the first place remains, even now, an open scientific mystery. NASA has been careful and honest about this uncertainty, repeatedly stating that this piece of the puzzle is still under active investigation, with a more complete final report expected later this year. This is a genuinely unsatisfying way for such a remarkable mission to end, a spacecraft that operated flawlessly for over a decade, taken down by a root cause engineers still cannot fully explain. To understand just how historically significant this loss actually is, it helps to look back at how previous Mars missions have ended. Back in 2007, another NASA orbiter called Mars Global Surveyor suffered a serious software malfunction that ultimately ended its mission. But even in that earlier failure, the spacecraft itself remained safely in its planned orbit around Mars, simply no longer functioning scientifically. Maven's situation is genuinely different and, in a very real sense, worse. This marks the first time NASA has ever accidentally physically lost track of a spacecraft that was actively orbiting another planet, an outcome that had simply never happened before in the entire history of American planetary exploration. It helps to sit with that Mars Global Surveyor comparison a bit longer, because the difference between the two failures is genuinely significant from an engineering perspective. When a software problem ended that earlier mission back in 2007, the spacecraft's physical hardware remained completely intact and properly positioned, simply unable to carry out its scientific and communication duties any longer. Engineers could still, in theory, track exactly where it was and confirm its physical location and orbital path with total confidence. Maven's failure removed even that basic certainty. The same abnormal rotation that drained its batteries also disrupted its orbital trajectory in ways engineers still do not fully understand, meaning NASA lost not just communication with the spacecraft, but also a fully confident, precise picture of exactly where it currently sits, and how its orbit may continue evolving over time without any power left to correct it. Maven's principal investigator, Shannon Curry, spoke about the spacecraft in remarkably personal terms during NASA's public announcement, describing it as the single best observer of atmospheric escape anywhere in the solar system, and comparing the sudden loss of the mission to losing a loved one. That kind of emotional language rarely shows up in official NASA communications. And it says a great deal about just how deeply this particular spacecraft's team had come to rely on and genuinely care about, a machine that had faithfully done its job for more than a decade straight without ever seriously failing before. It's also worth understanding what this loss actually means for NASA's broader presence at Mars. Before this incident, the space agency operated 3 active orbiters circling the red planet, Maven, the aging Mars Odyssey, which has been operating since 2001, and the Mars Reconnaissance Orbiter, in service since 2005. With Maven now gone, that leaves NASA relying on 2 remaining orbiters, both of them considerably older than Maven was, to continue serving as communication relays for the rovers still working on the Martian surface. Mars Odyssey and Mars Reconnaissance Orbiter have both, remarkably, continued operating well beyond their own original planned lifespans, but every year they keep running increases the odds that engineers may eventually face a similar kind of unexpected failure with one of them as well. Both of those remaining orbiters are, in their own right, remarkable survivors. Mars Odyssey has now been continuously operating for well over 2 decades, making it one of the longest continuously functioning spacecraft ever sent to another planet, while the Mars Reconnaissance Orbiter has spent over 20 years capturing some of the sharpest images ever taken of the Martian surface. Neither one was built expecting to still be working this many years past launch, and both have already required their own share of careful engineering workarounds just to keep functioning this long. With Maven's abrupt and still partially unexplained failure fresh in mind, NASA engineers are almost certainly looking even more closely at these 2 remaining veterans, watching for any early warning signs that might hint at a similar problem developing before it can turn into another sudden, unexplained loss of contact. There's also a quieter, more uncomfortable layer to this story involving budget decisions made even before Maven's sudden failure. NASA's proposed federal budget for the current fiscal year had already listed Maven among several long-running missions the agency was considering ending due to funding constraints, despite the spacecraft still actively functioning and still serving its important communications relay role for the Mars rovers. That detail adds an extra layer of poignancy to how this mission ultimately ended. Maven did not quietly get shut down through a funding decision. Instead, it kept working, kept collecting data, kept relaying rover communications, right up until the exact moment nature and an unexplained technical anomaly took the decision entirely out of anyone's hands. Despite everything, Maven's scientific legacy remains completely secure and genuinely enormous. NASA has already begun the standard process of formally archiving Maven's complete dataset, ensuring that everything the spacecraft ever recorded during its more than 11 years in orbit will remain permanently available to scientists around the world for years and likely decades to come. Researchers are still actively publishing new findings based on Maven's historical data even now, months after the spacecraft itself went silent. In fact, just weeks before NASA's final announcement, scientists, using previously collected Maven data, identified a completely new phenomenon in the Martian atmosphere, suggesting that the planet's thin, patchy magnetic field may actually shield it from solar radiation more effectively than researchers had previously realized. The spacecraft may be gone, but the science it made possible clearly is not finished yet, and likely will not be for a very long time. This entire episode also carries real, practical weight for humanity's future plans at Mars. NASA officials have specifically pointed out that data Maven collected about radiation exposure and atmospheric conditions is directly informing the safety planning currently underway for eventual human missions to Mars. Understanding exactly how much radiation astronauts would face on the Martian surface, and how the planet's remaining thin atmosphere and weak magnetic field might offer at least partial protection, is not simply academic curiosity. It is a genuinely essential piece of engineering information NASA needs before it can responsibly plan to send actual human explorers to the Red Planet, and Maven's decade of atmospheric monitoring built much of the foundation that future mission planners will continue relying on for years to come. So where does this leave things now? NASA has confirmed that a final, more detailed investigative report into exactly what triggered Maven's fatal rotation is still being prepared, expected sometime later this year. Until that report is released, the precise root cause of one of NASA's most productive Mars missions in recent memory remains an open question, an unusual and uncomfortable position for an agency that generally prides itself on eventually running down every technical mystery to a clear, confirmed explanation. Whatever that final report eventually reveals, it will likely shape how future spacecraft are designed and monitored, since understanding exactly how a routine, thousands of times repeated maneuver suddenly went catastrophically wrong is exactly the kind of lesson NASA cannot afford to leave unresolved. What makes this story genuinely remarkable, rather than simply sad, is just how much Maven actually accomplished during its unexpectedly long career. Built for a single year of service, it delivered over a decade of continuous, groundbreaking science, fundamentally reshaping how researchers understand the history of an entire planet, while quietly keeping humanity's rovers connected to Earth the entire time. Its sudden, unexplained ending does not erase any of that. If anything, it makes the more than 11 years Maven actually managed to deliver feel even more valuable. A genuine bonus achievement built entirely on top of an already successful primary mission that nobody expected to stretch anywhere near this far. There is one more piece of this story worth sitting with, because it says something about how NASA weighs cost against scientific value in an era of tighter budgets. Even before Maven's sudden failure, the agency's proposed funding plans for the current fiscal year had already flagged the mission as a candidate for termination, citing the roughly $22 million it cost to operate the spacecraft during the previous year alone. That is a genuinely small figure compared to the overall cost of building and launching a mission like this in the first place. Yet it was still enough to place Maven on a list of aging missions NASA was actively weighing whether to continue funding. In the end, nature made that particular budget decision unnecessary, but the fact that this conversation was even happening around a spacecraft still actively producing valuable science and still actively supporting rover communications says something honest about the difficult financial trade-offs facing every long-running space agency, where even genuinely successful, productive missions eventually have to compete for limited funding against newer priorities. If this story genuinely interests you, that is exactly the kind of real space exploration story worth following closely. Not because it is exaggerated for shock value, but because the real details, a decade of groundbreaking discovery and unexplained sudden failure and a scientific legacy that continues delivering new findings even after the spacecraft itself has gone silent, are already remarkable enough entirely on their own. Subscribe if you want to hear what NASA's final investigative report eventually reveals about exactly what went wrong out there behind Mars. Because even now, months after Maven went silent for good, this story is genuinely still not finished. Somewhere in NASA's archives right now, engineers are still combing back through every last piece of data Maven ever transmitted, hunting for any subtle warning sign that might have hinted at trouble before that final, fateful pass behind Mars. Maybe they find one. Maybe the true cause remains permanently unclear. One more small mystery left behind by a machine that otherwise did almost everything right for more than 11 remarkable years. Either way, Maven's story is a genuine reminder of how fragile even our most successful achievements in space exploration really are, and how a single ordinary Tuesday, on a maneuver performed thousands of times before without incident, can turn out to be the very last chapter of a mission that changed how an entire generation of scientists understands another planet. For now, the honest answer to what really happened out there behind Mars remains incomplete, and NASA has been refreshingly upfront about admitting exactly that, rather than rushing out a confident explanation it cannot fully back up. That kind of honesty matters. When the final investigative report eventually does arrive later this year, it will hopefully close out one of the more genuinely strange chapters in recent Mars exploration history, giving both scientists and space enthusiasts alike a clearer answer to the same question that has lingered since that first quiet, unexplained silence back on December 6th.